Okay, we have problem 6.7 now to take a look at. And we're given four different energy diagrams here. And we're told that potential energy is on our y-axis, and then the reaction coordinate is along the x-axis. And we have cases A, B, C, and D to compare here, and a few questions below. So question A asks us to compare energy diagrams A and D. So we'll take a look between A and D, and we'll assume that everything is the same. All factors are identical, so concentration and temperature are the same for these two processes, but we want to know which would occur more rapidly, and then what is an explanation for that. So let's look at our reactants and draw a line here for both of these. And we can see that the activation energy that I'm indicating needed for these processes are different. And D has a lower activation energy. So that process would be more rapid. That would occur more rapidly. So D, because of the lower activation energy. All right, so let's take a look at what we're asked in case B here. So we're asked to compare A again and B this time. And we want to know which process would more greatly favor products. So favor products at equilibrium. And then we're asked to give an explanation. So the answer would be process A would more greatly favor products than process B, because process A is an exergonic reaction. And if you remember, that means that the products are at lower energy than our reactants, and we end up with this negative delta G value here. We see in reaction B, they're at the same energy, the products and the reactants. So the products are at lower energy than reactants in process A, being exergonic, so that would favor products at equilibrium. So B for that one. Let's take a look at example C here. And we're asked, do any of these processes show an intermediate? So if you recall in previous lectures when we had multiple transition states, between those, these minima would be intermediates. So even if you have a two-step mechanism with two transition states, you could have an intermediate, but none of these, so none, have an intermediate. Do any of the transition states exhibit, do any of the processes exhibit a transition state? Yes, all of them have a transition state, right? The energy maximum here, right, would be considered a transition state. So none have an intermediate, but all have at least one transition state seen, or all rather have exactly one transition state. So let's take a look at process or question D here. So we're asked to look at energy diagrams A and C. So let's compare those now. So we want to compare A to C in example D here. So we want to know in which case will the transition state resemble reactants? So transition state resemble reactants more than products, right? So more than our product. So if you recall, due to the Hammond postulate, whichever the reactant or product is closer in energy to the transition state, it would resemble either, again, the reactants or products, respectively. So in A here, we see that we have an exothermic reaction, and our reactants look more like our transition state. They're closer in energy. And then in C here, we have an endergonic process where reactants are lower in energy than our products. Products are higher in energy, and they resemble the transition state. So we want to know reactants resemble transition state. So we would go with process A in this case. All right, let's look at question E here. So we're asked in E to compare diagrams A and B. All right, so A and B for question E. And everything is equal, everything is identical. Which process will occur more rapidly? So this is another instance where we could look at our reactants compared to our transition state and look at the relative activation energy. So between A and B, we would see that process A would occur more rapidly because it has a lower activation energy. So process A has the lower activation energy. All right, so example F now. We're moving along, we're almost there. So question F asks us to compare processes B and D. So B compared to D, which would greatly favor products at equilibrium. So let's explain. So process D would more greatly favor products because process D is an exergonic process, and the energy of the products is lower. So lower energy products than the reactants. So again, which will greatly favor products at equilibrium, it would be process D. All right, and then our last question here asks us to compare diagrams C and D. So let's go back, let's look at C and D for example G. And in which case will the transition state resemble products more than reactants? So again, we want to know products that are closer in energy to the transition state. So we'll compare C and D and look at the relative energy between the transition state to the product. So we see process C would more greatly resemble reactants at the transition state because they're closer in energy. I'm sorry, more closely in energy to the product, sorry. So we're asked to resemble products in this example here. So again, diagram C shows us, due to the Hammond postulate, that the transition state would more closely resemble products because they are closer in energy. All right, so we'll pick up with example or practice problem 6.8 in our next video.